1 2 1 2, I'm Ron. Welcome to the stream. This is going to be an impromptu live stream of teaching and learning C++. I'm running off notes and I don't have a huge plan except that I've studied C++ on and off for 3 years. I've made maybe 30% of a game engine in C++ and a few programs. That is no easy feat with the 3D maths and everything for a game engine, and so let's just go. These will be depending on viewership and the chat and subscriptions, probably quite regularly, maybe a couple of times a week. So let's say hi to everybody. Is that working? Sweet. Okay, I'm using Visual Studio and the cheap microphone, which I'll replace when I get home with my usual microphone. So you open up Visual Studio and you'll be presented with this here. Not this, this is the game engine. I'm going to start a new project and let's have a look. It's been a while since I started a new one. Create a new project. This is Visual Studio. You can just get it from Google. Microsoft product, Visual Studio. Let's have a look. Empty project. You can choose your language here, C++, and it just filters out the choice of options. Also, when you're installing Visual Studio, you'll have different packs you can choose. You just want the ones that are associated with C++ and Windows. If you don't know, just if it has C++ on it, have a little read. Probably you'll need to install it, but maybe not all of them. There'll be Linux packages. If you have Linux, you don't need it. If you do, you do. And also there'll be options to install C++ and mobile apps. So it will support compiling on a mobile phone, which means you can run the program on a mobile, but it might be a while till you can get to that stage. It might not. So it's up to you if you do that or not. Doesn't make a difference. C++, all languages, all platforms. Even got Xbox there. All project types. So just leave it as it is, and then we will go with. Let's have a look. I think this one. If I'm not sure, project name. Let's go C++ project. You can put a name in that you want. You're going to make many of these. Hit create. It's going to give you some of the basics. Okay, that looks a bit intimidating. Let's get in this one here. And here is our file. I'm going to switch this over as well. I'm just letting you see some of the setup because you might have to do what I just did there also. And now I don't need to share the screen. Maybe I will for now. I'll bring that up there. Okay, let me get my stream on. This is just me testing everything's working and connected. That was my confused face. Sweet. If we get pauses like this, you can hit the left and right arrows on the keyboard. It will go forward 5 or 10 seconds just in case it's installing. And you're probably not watching this live. Sweet, sweet, sweet. Okay, C++. Let's pull up some notes that we have. This is going to be quite a raw lesson, a raw class. First time teaching C++ from the foundation. Okay, what you want is, okay, Windows Visual Studio. Here is your Solution Explorer. I'm going to close that. So if you ever lose this, go to View and Solution Explorer. You've got it here. I think you can move it about. You can let go on the screen in different locations, and it's going to put it where you let it go. Put it at the top, which is quite ugly. Really you want it on the right, maybe on the left, but common use is just on the right. Slide it across, and this will organize all your files. You'll have header files and source files. So we're going to right click source file, go to add, and add a new item. And what you want right now is a new C++ file. And you're probably going to call it main. So your most C++ files will have a file called main and then .cpp. So every C++ file will end in .cpp. And we press add, and now you have your first file here. So these are just filters. These aren't doing anything. They're just helping you manage your actual files, like here. So you might have a file in the headers or in resources, but this is your source files, your source code. So source code is the name or a name for the code, the text that drives the program. And here, let's see, are your lines. You have line numbers here. Soon you're going to be writing thousands of lines of code. And the compiler, which is something the machine in the back end will go through your lines one at a time in order. It's important to know, but you might think it's obvious. Maybe it is a little bit, but your code will run from top to bottom. Okay, so let's look at some code. We'll go straight to practical. Okay, so I'm going to give you some code, which is quite standard. And also you see how it's filling out, it's trying to guess what we want to do. So this will speed up coding for you. This is why Visual Studio is so good. 20 years ago, you was typing a lot more. It wasn't able to guess as intelligent. But yeah, Visual Studio or other programs are going to help. It's called IntelliSense. So IntelliSense, which you can turn on or off. You can probably change how it works. It's something that's, as you're typing something, it will try and guess, and it will give you the nearest suggestion. I think if you press, let's have a look. If you press the space. You can definitely, so I mean you can click on it anyway, but it's playing up at the minute. Okay, so let's go with some code IntelliSense. So every program you do will start like this, and I will explain it shortly. But we want to just get a bit of code on so we can explain it better. Int main, and you're going to be using a lot of brackets. And whilst we're here, there's your standard brackets, curly brackets, and like your diagonal brackets. They're all next to the right side of the keyboard, so get familiar with those. And also on the same side as your semicolon, you're going to make sure you know where that is as well. Okay, so in main, I'm going to do something here. You can just copy all of this. Okay, if you see two lines, it means we're doing a comment, which means this is not code. We can write anything here. After the two lines are two forward slashes, and This is a comment. And sometimes you're going to write so much code you forget what certain things do, so you'll put comments in everywhere. Or you might leave a project half finished and you might need some notes for the next day just to remind yourself something. You're doing that with comments. And you'll see other people's code. You might download something and they will have comments as well for you to read. Okay, integer main, int main. What does that mean? Let's see. And we're going to, you're going to guess some things, you're going to guess some things right, some things wrong, some things will be obvious. Hello world. Okay, is that all I'm going to hit? I'm going to hit this here. I'm going to hit run, which was the play icon. Just press back on your arrow key if you missed that. And sometimes the first time running there might be an issue, so we're just going to make sure everything's ready to go. Computer's just thinking. Is it thinking or is it done? I think it's still thinking. Yeah, oh, we don't need that. And then we go here. Okay, so this is the console. Now you probably want to run a program and create an application that's nice with buttons at the top, file open, a nice white background, but you're not going to get starting just there. It's going to take a minute before you get there. You're going to start in the console. Why does it start in the console? I guess because of the language C++, the types of programs you build on it often start from nothing or next to nothing, and so you start to build a world, you start to lay foundations, and visuals come in a little bit later. They can come in immediately, so don't worry too much. This is your console, and all this is rubbish. We didn't do this, but what we did, we wrote hello world. Okay, so let's break down what we did. I'll click this X here. So the first thing I want to do is give you an intuition rather than teach. You probably guessed, whatever you write here, let's just write into it, an intuition. You don't know how this is working, but you know that it's something to do with that. I'm going to hit cancel here. This is just trying to load up some things to help us that we don't need. I hope that don't keep coming up. I'll fix that. Okay, so now we've written into it on the screen. I'm just going to check messages. Most of my subscribers aren't expecting me to teach basics, so nobody's in the chat right now. That makes sense. But I'm talking to you, who came after right now. Okay, so I'm just pulling up my documents. I can teach you maybe 70% of this from my brain, but I want to give a good foundation. Maybe I will learn something. Okay. So let's go to include. So we wrote things to the screen, to the console, which is output. We streamed, this is the language you'll use, we streamed some text to the console. So this is the input output stream. This is a file we're including. So hashtag to include. So if we wanted to include graphics pack, this doesn't exist, but if we wanted to include graphics pack header file, we would just do that. Have I spelled something wrong? Okay, it's giving me an underline green because it can't find this file, it doesn't exist. That doesn't matter. But this is how you include additional files that already exist or that you've written before. Now, if it's a file you created, you will do it in speech marks, like this. And if it's something that exists within the C++ library or C++ foundations, you will use the curly brackets, which is why also. So we're going to include something, use a curly bracket, and it's going to suggest all the things we might include. So it's called the input output stream. Click that. And that will give us the ability to output, you see when we got rid of that there, this went green because it doesn't know what this is, which that is, by the way, console out, and this is to end line in the console, but it's gone green because that keyword, that phrase, is console out. It has no data or no reference point for what that means because it exists within the input output stream file. Okay. Documents will say this here. This tells the compiler to include the standard input-output stream library, essential for performing input-output operations like reading and printing input. So we put something on the screen, but we might want to say to the user, hi, what is your name, what is your password? That would be the input. So that input-output stream file allows us to do both of those things. And I'm elaborating because most files and most programs you write will have that. Even if you create a 3D game without a console, in the back end you'll be doing that for debugging, for checking for errors. You might have crashes and you might want to write on the little console just here, you might want to say there's an error on this line, there's an error on this line. So this is your new friend, the console. Okay. Now every C++ program has an entry point, and in C++ it's called main. So we will have lots of different functions. We might have a function called foo bar. You tend to see that with coders, and this is how you write a function, which of course I'll break down. And then you might have another function, foo bar, next function, and when you run a program, the compiler will look for main. So your program will start, it will go from line 1 until it finds main basically, and then your code will start running here. So whatever you create is going to be connected to main. Even if you write other functions, main might just be 2 or 3 lines, but that's where your entry point is. So let's go here, entry point. Okay, now functions have something called a return type, and the return type of a function is written at the start. Now int is short for integer, which is a number. Short for integer, it means a whole number. Okay. So it means when this program is run successfully, it will return a whole number, and you indicate that with the keyword return and the number. Now, what that would do, it will send something to Windows to say that it's ran successfully or not, and you as the coder can choose what number to send. And in the main function, it's not really that relevant. You just need to return a number. You return 0, and Windows knows it ran successfully, or at least the program's exited. Now there's other functions. Okay, I'm going to say my tea ran out, so we've got some Ribena, some blackcurrant from the vineyard in Italy. What was we saying? Yeah, so you need a return type. So return 0, return 1, it should still run. We press play, and at the bottom you can see here it's compiling the code. Let's see what we get here. Let's just close the symbols into it, and then it return after this line here, which corresponds to this. It drew a new line with the end line keyword. I will talk about that. And then it returned 1. It told Windows we're finished here. And then it would go to the function. So this is the function. After the return, it will go to the function that called this function, which you're not going to understand till we see it. But because this is that entry point, because this is main, no function called this. This is the start, so it just ends. It kills. It's finished. Exit. Okay. So you include the input output stream, you choose the return type, which for main is always integer, to say we're going to return back to Windows basically. You have brackets here which indicates it's a function, and then you write all of your code inside the main function. So integer, the function's name, we tell it it's a function, and then we have to start defining the function. You do curly brackets, new lines, and you write all your code inside. Function code goes here, and that would be your first program. Now in Visual Studio, if you select some text, and we're going over here, there's a white and green comment icon. If you click that, it will turn your code into a comment, so it's put the 2 lines before it. So this is no longer code, because if we have 2 main functions, it's probably not going to work, or it's going to do something crazy. It's going to say, look here at the bottom, function already has a body. So it's saying there's a function called main, and it already has a body. A body is the code. So it's saying it's come to this line of code here, it's starting to fill out the body, but it's saying you've already got a function called main, because every program only has 1 function called main. If you have 2, it doesn't know which one to pick, so it won't run. That's your first error. Okay. So if we highlight it all and press this here, it's turned it into a comment, so it's no longer code. That's why the color's changed. You press play and it's going to run. You can cancel that if you get that on the screen. That just loads symbols. So the symbols are something in the deep within the computer and the language, and Windows and Visual Studio, that help to debug when there's issues. So if you've got a really big program and there's some errors, you don't always know where the errors are, and the symbols will help you to point to the errors, but for a little bit of code you don't need that. Okay, but we can keep that here, and we can say the code goes in the middle. We can say all C++ programs start at the entry point integer, as it means a number is going to be returned, main. Okay, so if I get rid of this and press play, we're getting some errors. So I want you to see where the errors are. They're at the bottom of your screen here, and I'm getting, it says here, cout is not a member of standard. So it doesn't know what does cout mean, what does console out mean, and it's saying here end L. By the way, end L is just end line. It just means it's going to do a new line, like when you press enter on the keyboard. And yeah, it's just the same errors basically. So you put that back in. Okay, one thing I didn't mention was std, and this is something called the standard library, which is where you have keywords and functions and tools that are all collected within a namespace, within a space in memory in your files that belong to something called the standard library. And to use those, you basically tell it you're calling something from the standard library. It's something called a namespace, so it's where lots of different names of functions are grouped, and then you do 2 colons, so it's near the right shift, and then these are all the different functions and different types of data that you can call upon. You don't need to use most of these. Some of these I've never even seen in 5 years, 3 years, on and off. Some of these many people have never seen. So we call std, which means we're using the name grouping or the namespace, which is standard library, and then you might do cout or cin, and you'd write something to the screen. So let's see. Let's do standard library console out, Now these brackets here are when we're going to stream something into the console. So these are the angled brackets. And for every new thing that we write to the screen that's different from the previous one, we use brackets. So we might do text, a line of text, and then you do a full stop and a space, and you do a comma, no, not a comma, you do another bracket, another line. Now I just know I'm going to get something very simple wrong because I didn't plan. Okay, so also from the standard library within the namespace is something called endline, as I briefly mentioned. So this will do right into it, but let's go back to hello world and line of text and another line. Now there's going to be an error here because if you notice here, so what do we have? So we wrote hello world, which corresponds to the first line, and then we wrote here standard namespace end line, and then we had a line of text and then another line. But notice we only got one new line. Those two are on the same line. Even though I wrote another line, it's still on the same line because we didn't put a new line in between this and this. So remember the angled brackets are for each new item, and then how do we do a new line? Standard, 2 colons, end line, and then we're doing something else, some text, so we want 2 more brackets, another line. Now of course you could just put all of these in one sentence, right? This could all just be one long sentence. Let's have a look. Okay, so we have hello world, a line of text, and another line. So this is all some console out little functions. I'm just going to pull up the docs for maybe some other examples, but I'm just going to show you how to do a new line in an easier way. Search for console and put examples. Okay, so another function, I'm going to call it another function, another little trick we can do. So this is going to give us a new line. We will say how about, and then let's do a / n and / n and / n. How about, and then another. How about many new lines? Question mark. Oh, one thing I missed, by the way, is after every line that isn't a function or a bracket, you do a semicolon. It's the most important thing, and you will forget this many times. And this tells the compiler that the line of code is finished. So / n here, you keep it within the brackets, you don't need to close the brackets, so you do it within the two, will give you a new line. Simple. So now we have 1, 2, 3, 4 new lines for each of these. And here, so let's just remember the angled brackets, we're going to add something else. We want to add a new line here. And then we're going to say, so with the from the standard space, we're using the function console out, shortened is cout. We're going to say, I wonder what / I wonder what this does. So I've done a / t. So here, I wonder what this does. Instead of a space, it's done a tab, which is like a big space. / t, / t, / t. can just bring this onto the screen here, console applications. So some old games back in the day, and even today actually, are running the console, and you can see here some of this text is like lined quite neatly, and that's done with the /T with the tab, and even here things are made quite neat. I'm going to zoom in, you can see that. So that is all done in the console with the commands that we're using now. Okay, I wonder what else we've got. Can I think of anything else for the console? You can do different colours. One thing, so when you're going through Windows, you might have something on the C drive. So you might look for a file, it might be in C drive, my documents, and then it might be username, for example. Let's see what this does. First, let's get a new line. And you see here, see my documents. There's no /, there's no / here, because these // are used as like a key, like a function to do little tricks. So if you want to write a / to the screen and not to make new lines, you do 2. You do 2 together, and that should give you 1. So now you have a /. So when you do just 1, it's expecting an N or a T to do something that manages and changes how the text is displayed. If you do 2, it knows that you want 2. Okay, let's have a look if there's anything else. Let's see what happens when we do this. Hello world /A. Okay, so on some compilers that will give an alert, like a beep, but it depends on the computer. I don't think there's anything else that you need. So I've done almost all of my console debugging with that. You can change colors. So if you want to Google or ChatGPT or Grok how to change the colors of the console, you can change colors. If you're doing a game in the console, you can do that as well. But what you need, just as a refresh, is /N for new line, T for a tabbed space, and STD to use the standard library. So you would have STD cout console out or STD end line. The next one is going to be STD in, which is console in. Okay, so what can we do? We can leave that there, and then we will just put 1, 2, 3, 4, 5. I like 4. Let's do 4 new lines. And let's do a comment above our code here. Testing out console out, which is cout. STD cout. Now testing console in, which is standard in. Okay, so what if you want to put some data into the console, such as somebody's name, and then do something with that data? Okay, so what we're going to do first is we're going to say from the standard library, cin. Now notice we're not writing to the screen like this, we're sending information somewhere, so the brackets are the other way around for console in. So it's the stream as I mentioned, but we're not putting out, we're not spitting out, we're receiving in, so it's just backwards. And then we're going to say we're going to, whatever we store, we're going to take the name, so we're receiving their name, and then we're going to do the semicolon. Now it's gone green. What does green mean? It means it doesn't know what name is. So we're going to store something, a name, but it's like, what does that mean? So this is where we'll use our first variable, and anything that's text in C++ is called a string. So what we want is a standard string. So we're creating a string, so something that will store a variable, that will store some data that is text. So we call it a string, and we're going to say it's a name. So this line of code creates a variable, so something that can change because we're gonna get the user to type it. Creates a variable, we got that right, called name, which is of data type string. Once again, here we create a string, a data type string, and give it the name. Okay. Now, what other question might you want to ask someone? So let's create another string. You might want to ask them the town they're born or the city they're born. So semicolon. So now we've created two strings, and notice the green line here has disappeared. So when we run this, behind the scenes, the compiler is going to create a data type called name, and it's going to put some memory aside. It's going to say to Windows, I want you to put some memory aside for a variable called name that's going to have some letters and some words in it, potentially. We don't know how big it's going to be, so you need to put some large space, get it allocated, put it to the side, and then we're going to do that with something called city. Now, if we just get rid of that a minute and run the program, let's see what we got. So we've got the usual that we did already, but you notice nothing's happened on the screen, but behind the scenes Windows for sure has created a string and called name. It's created another string called city, and then it's continued to go down, and then the program's ended. So we know whatever this does, we know it's worked because it's wrote everything to the screen, it's closed safely, there's no errors. So we have just created some memory, we've given it names, and then we've done nothing with it, but we've just commanded, we've coded and told Windows what we want it to do. Okay, so now let's go back to standard console in. So we're going to take some information, use the angled brackets, and we're going to put it in name. So now if we run it, let's see what happens. We have a little problem in the code, but look, if you look here, it's waiting. If I make it bigger, it's not ended, it's just waiting for us to type something, which is this line here. Because of the arrows, it's paused until we type, and then whatever we type is going to be saved in the memory that we can access with this name. So name will allow us to recall and use the name that we type in here. So I'll type John, press enter, and the program will finish because the next line is finished. So what we want to do really is before here, standard, we want cout, we want to write something. We use the brackets that we're used to from before, and we'll say, what is your name, question mark, and then we'll do a space, semicolon to end the line, and then after one space it's going to do this, it's going to expect us to type something. What is your name is done the space. You see, we're in control, we can do a space, we can do a new line. What is your name? It wants you to type something, and then it will end. Okay, but that's useless, right? So let's do something with that. So we type a name, and then we want to give a message to the user, and we'll just say, I like the name, comma, space, and then we're going to write something else to the screen. So when we write to the screen, we're doing like an outflow, and then what we write here is name, and you notice here it's guessed what we want to do. That's because we've created the string here called name. So this is now a variable that the program can use anywhere within this function, the function that is created in, which is main. So you click name, or you can just type it, and then you press semicolon, and it's going to write I like the name, comma, space, and then whatever word you've written in there, or even a number, whatever you wrote in there is going to be written. It's very simple. What is your name? So you think I'm going to write John or Ryan, but what we're going to write is a full stop and one of those and one of those and one of those and one of those, and we're going to press enter, and what's it done? It says I like the name, comma, here, and then what did we type? We typed this, so there you go. It's done exactly what we told it to do. Whatever we type is what it writes. And it's good you see it working in a strange way, because you have to understand whatever you want it to do, it's going to do. So let's be orthodox. What is your name? Ryan. I like the name Ryan. So even though we've called it a name, it's just a container, a variable of letters, of numbers, but stored in a string, and it will write it to the screen, or we can maybe send that to a printer, save it to a file. We can use it as a character name that we draw in the world. We can do anything. However, if you write numbers in a string, it will still save it, but you can't do any math with that number. You can't do any mathematical operations. So if you want to do 5 plus 5 and you've got a string here and a string here, add it together, it sees those numbers almost like letters still. So it will still do the 5 on the screen, but it can't do any maths with it. If you want to do maths with the input and the data, you need what we've already mentioned, an integer. So you need an integer. So let's say, let's ask how old somebody is. No, do we want to do that? No, we don't want to do that. We want to say, so standard library, console out, we're going to put something on the screen, give me a number. And then we're going to do a space, and then we're going to do console out, and we're going to say number 1. Now you can't do spaces in variable names, so you just capitalize the next letter, the next word. Number 1, and then we're going to say we want a new line. You don't have to, you can choose how you format it. Give me another, and then number 2. I've gone a little bit wrong here. What do we do for writing stuff to the screen? Console in, the arrow is the other way, and you say number 1. Give me another. Standard. Okay, it's gone messy there, and it doesn't matter. Once there's a colon, semicolon here, you can write it wherever you want. but just keep things neat. And I mention that because some programming languages, it doesn't matter if you do a space or a tab. If it's Python, every time you do, I think it's a tab, it thinks it's a new line, a new colon. You don't do semicolons in Python. So if you do a tab, it will think you've gone into like a loop, or you've gone into some kind of other, what's the best way to say it? Just with Python, it's different. We'll say that. Okay, number 2. Okay, and this is green because it doesn't know what number 1 and number 2 is. So you have to make the variables, and as I said, it's an integer. Now these are one of the basic data types in C++, so you don't need the standard library. You just write int, and it means you're going to be storing a number, and you're going to store another number. So we've created an integer called number 1 and number 2. This time round, instead of doing it on 2 new lines, I just did a comma. Okay, so let's run this, and this will be a bit messy. Oh no, I think we've got a new line in. What's your name? Ryan. I like the name Ryan. You see here. What did I miss? A new line. So /n. Give me a number 5. Press enter. Give me another 6 or 7. What happens when I enter the other number? It goes to return 0. Press enter, and it's finished. Second. I have a lot of screens going on. Okay, so why would we ask for 2 numbers? So as I was saying, when something is a string, like a name, the city that you're from, which we didn't use by the way, then if you type a number there, it can't do any maths with it. It can't do any operations. So that's number 1, number 2. Now let's say we want to add those numbers together. What would we do? We would say, first we need to store the result. So we're going to create a new integer called result. And we're going to say the result equals number 1 plus number 2. Use IntelliSense, finish it off with a semicolon. So now we have 3 integers or 3 numbers. We have number 1, which the user will type. We have number 2, which the user will type. And then we have another, so they can choose whatever they want, but result will always be number 1 plus number 2. And then you want to write the result on the screen with standard cout the sum is, and then what's the sum? Result. Okay. What is your name? Let's say Lee. Give me a number. 4,500. Give me another number. Let's say 5,500. The sum is 10,000. Looks good. Okay, let's do this. What's your name? Lee. Give me a number, let's say 10.4. I made a mistake there. So I want to demonstrate. Give me a number. 10.5. Okay, so we're using an integer. Press enter. And it's gone straight to give me another number, and then it's answered the question. I didn't get to type it in. And this is because here we are asking for a number that is an integer, and an integer is a number without a decimal place, without a point, but I put a point in. So what happened was the 10 went into number 1. The 0.5 was still left on the stream where we typed to the data, but it can only take before the point. So then the 0.5 tried to go to the number 2, but they don't deal with what's called a floating point, anything with a decimal space. So that just went to the next line as basically an error. and then it just wrote out the sum is 10. Now if you wanted to do points, you would do float, and okay, this is going to trick it a little bit, but I'm going to just try and demonstrate how to avoid causing yourself a lot of pain. So give me number. So the numbers now are going to be floats. So a float is a number, as I said, that can have a decimal. So pi, 3.14, so on. So let's say, what was it, 10.5? Give me another. So this time it's worked because it knows that you want the 0.5 to belong to that as well. Give me another. Let's say 9.5. Now, and let's say 9.6. Now you notice here it says the sum is 20, which is wrong. Okay, the sum should be 20.1. So why is that wrong? It's because when we've added number 1 and number 2, which is 10.5 and 9.6, we're storing that in result, but result is an integer which can't handle points. So let's change that to a float. And what's your name? Lee. Give me number 10.5, give me another 9.6. The sum is 20.1 because it's stored in a float, or what's called a floating point number. It's able to retain the data after the decimal. Now there's something called casting. Let's have a look here. Which is when you change something from one type to another. So we're writing result int. There's different ways to do this, so it depends sometimes. What's your name? Ryan. 10.5, 9.6. Okay, so it's result is a float, but here I've done something called casting, which, as I wrote it out, I told the compiler, Visual Studio, behind the scenes, to change result from a float to an integer. Now maybe you just want to round down, or you want to round. So if you just want to quickly get rid of all the data, maybe it was like 10.567. You just want to see the integer, the whole number, which you might do this in money if you want to get rid of the pennies and so on. In calculations, in shadow and lighting and physics calculations, you might want to just lose some data. You would just do that. Excuse me. So you want to change it to an integer, and you want to go put the brackets around the variable that you want to change. Now what happens if we do it the other way around? Integer, float. So this time we're going to take only single numbers, whole numbers, but then when we print it out, we're going to turn it into a float. So give me number 10 and 5. Okay, it's written 15y because it has no extra data. So it's cast it, it's called a cast, it's changed it into a float, but there's still no new data at the minute. It can't just create something after the decimal. So it did change it, but there's nothing there to produce. Okay, 1 second. Maybe let's do another example. So we will keep that like this. And we will say, let's create an integer called age, and a float called height in centimeters. So you could be 185 centimeters and a half, so 0.5. So that's a float. So it's all about knowing which data type to use for which situation, basically. Age, I mean, you're 30 or you're 31. You can be half, but you wouldn't put that on a form. So yeah, let's ask the question. Console out. what is your age, and then you would have console in age, so it would be stored there, and maybe you do a space and copy and paste all of this. Let's give them a new line for each question. New line, what is your height in centimeters and millimeters? We can just leave it as that because we know. And then copy here, and then you can say standard console out. Then you just want to relay that information back on the screen. Your age is space, and the operators here, so these are your operators. Putting something on the screen, what did we call it? Age. So your age is age, and then we don't need a new line, we can say full stop. So that's going to do a full stop, which is a string after the number, after the integer. Your age is age, your height is space, and what did we call it? Height in centimeters. Click that. Did we do a new line? So let's just check everything because we're just doing it without a plan. So we're creating an integer age, like we did with number 1 and number 2 and the results, and then a floating point. Floating point number allows for decimals. Decimal. So a new line, what is your age, and a space, and then we will take their age on the same line, and then on a new line here, what is your height in centimeters, space, and then we'll take height in centimeters, and we'll do a new line and say your age is, and then we'll output the age, and your height is height in centimeters, and then we'll return the program. Or maybe we can, instead of returning, we can do standard cin. We'll say pause. Now, if we create here a standard string and we'll call it pause, it's going to wait until we type something here, but I'll show you what I'm going to use there. I think you probably will know. What is your name? Ryan. Give me a number of 3 and another 3. The total is 6. What is your age? Say 30. What is your height in centimeters? Let's say 190.5. Your age is 30, so integer. Your height is 195. Now all the messy code at the bottom that we normally see to say Windows is finished is not there because it's the console input is waiting for us to type something else and store it in pause. What does it want us to type? Nothing. We're just saying until you press enter, so we can type, but basically it won't finish until we press enter. So it just makes it clean. Press enter, give it a full stop. It wanted something, but it was instead of having all this mess come. Okay, I'm gonna leave that there, and just a little. How long did we go for? That was a short stream. 45 minutes, that's a class length. So what did we cover? A little recap. We covered includes. So if you write the comments in, it will just instill this into your brain. Including header files or core components for C++. Okay, we have our entry point here. Entry point. And the data type return to Windows integer, and then here we have some console out, so let's get that right. Console out function from standard library, namespace, it's called a namespace. Let's have a look here. If you type namespace, it will change the color because it's a keyword, and we will come to that one day. And cout is console out. Something's going out, so your operators are like expressing to the screen, and everything is in your brackets. on your compiler you might have had an alarm, an alert, but not on this one. So from the standard library end line, it's like carriage return, pressing enter. And the same again. And this here gave us a new line. And then we found another way to do a new line. We use the operators to join together. So here and here, we use the bracket, the angled operators, new tabs, and then we know to do two forward or backslashes. It's the same, is it the same? No, two backslashes if you want backslashes. New lines again, comments, string, and 1 second. One last thing I will show us using namespace std. Will that work? Maybe we need that. I do have this habit of saying we're finished and then just not finishing. I need a reference here. Wait, oh no, it worked. It thought, because I did a typo before, but then I got rid of it. Sometimes it's slow. So you notice now, let me delete that. If I write string, it's going to say what's a string. It doesn't know what a string is because you need to say it belongs to the standard library and call it with the 2 colons, and then it knows that you're calling upon standard library and getting from within standard library a string. So we type in standard library std or stud, std, stud, standard, people give it different names. We type in that for cout, for string, for cin. We type in this every time, every line, and it's a lot. So if you say, look, I want to always be using from the namespace or the namespace std and then a colon, you will no longer need this. It knows what you want. So it sees here, it knows you want string. Let's have a look. I've got it twice for no reason. So now it's letting me have string. And why is that gone green? Just because I didn't finish string, city 2, colon. So you finish that line. If you don't finish your line properly, sometimes there's an error here, or sometimes the error goes on the next line. So if you go to using namespace, you can take out all of the STDs. That deserves a subscribe, right? And it's all gonna, in theory, work the same. Okay, what's your name? Give me a number. So if we do 1.5, we're gonna crash it. It went straight through. It messed it all up because we asked for an integer, gave it a float. And that's where you're gonna have to look at error management. Like you might want to say, and we'll come back to this in the next class, what happens if a user types the wrong thing in? Could they break a program? Could that cause another program to break? Could that cause them to get access to a file? Could they hack into something by typing the wrong thing? Could they see something they shouldn't? So you have to manage all of those. Give me a number. 4, 5, what is your age? 30, what is your height? Let's just say that. Want some more data, and so it all works the same because I use namespace. Now when you do this using namespace, it brings some data into your application, into your program from the standard namespace, but some of that data you might not use. So it brought in the console out data and the string data, but there's other things that aren't listed here from the standard library that it's brought into the program that you might never use. And so that could slow down the program, which is why some people don't use this. But because it only slows it down so little and computing power today is so strong, a lot of people don't mind. Do I use it? I don't use this actually to be more efficient, and it's up to you. Homework. Go find out how much different